Hi, welcome back for another 8 Caillou challenge. This is called Find Multiples of a Number. Nice short description, I'll just read it off. In this simple exercise, you will build a program that takes a value, integer, and returns a list of its multiples up to another value limit. If limit is a multiple of integer, it should be included as well. There will only ever be positive integers passed into the function, not consisting of 0. The limit will always be higher than the base. For example, if the parameters passed are 2, 6, the function should return 2, 4, 6, as 2, 4, and 6 are the multiples of 2 up to 6. So very clear there. I think you're good. I also think you can solve this challenge, so go ahead and give it a shot. Come on back when you're ready. First things first, I definitely encourage you to rename variables when they don't help. So I already know this is an integer, right? It says int right here. This name doesn't help me in any way. For me, I would even use the letter n, which is a common variable name for an integer, over integer. In this case, I think I can be a little more expressive. I'm going to say multiple. I like that name better. But go ahead and use whatever you like. So the key to solving this then is, well, I'm going to do it two ways. We'll stick with the usual theme. I'll do it using basic building blocks, and then after that I'll show you a one-liner using LINQ. So first things first, we know that as part of the contract we have to return a list of type int. The generic parameter type here is int. So let's go ahead and make one of those that we can return. Usually when I just make a data type like this for returning, I call it result. But you could put a more meaningful name. You could say multiples. And then it's important, this part, we assign it, we actually create a new list so we can actually use the multiples. If you do this, you declare it, and you don't actually create the list, and then you try to access the list, you run into errors. So make sure that you create it. Good. And then a second little piece of setup here, I'm going to make a local variable here called current that I'm going to set to multiple. And by this, what I'm achieving is I'm basically caching whatever the original value here is, because I plan to increment this current value all the way up until I hit the limit or go over the limit, and then I know how to stop. I know when to stop, I should say. And so the idea is that we have our list ready. We're starting with the first value, right? It would be 2 in this case. And then I'm going to use a while loop. I don't know that we've used while loop much in the 8 Caillou series. And the idea is that it's just like your for loops, but it's nice when you don't know how many times you need to run something. So with for loops, we have, int I equals to 0. I is less than some value. You can increment or decrement, whatever you want to do. I don't know ahead of time how many multiples I'm going to have to add here. So the while loop plays nice. You just have to make sure, there's a little bit of danger using while loops, that you don't get stuck in what's referred to as an infinite loop. You have to make sure that you're updating your state so that you fall out of the loop at some point. So I can say while current is less than or equal to limit. They said in the description to include the limit. And so what do I want to do? Well, I want to add each multiple to the list of multiples, right? So we want to add that too. We'll use this as our concrete example to work with. So I would say multiples, the list. And if you want to look up the list collection here, you can use your doc pages for that. And you'll find it has a method called add to add values to it. That's how you sort of insert values into it. So I'll say add current. And then this is like what I warned you about. We have to update current, right? If we just leave it like this, current never changes, and it just keeps adding the same value over and over into multiples until your program crashes. And so that's where we come in and say current plus equals multiple. So in this case, we added 2, right? And our limit was 6. So we're going to add 2 we set current to 2. We processed it. We added the 2. And then we're saying, hey, we have that value of 2, but add 2 again to it to get up to 4. And then you could see how 4 will be processed the next time. And then you add 2 again, because we're referring to multiple and not current. Multiple is staying the same. And so I'll add 2 each time I go through this loop. Eventually current will get large enough to hit the limit. And again, in real life, you would do this kind of error check, and these things where they tell you it'll never happen is fine for this isolated environment, but a friendly reminder that in real life you have to check for those things. And then after you fall out of the while loop, when you exceed the limit, you can simply return your collection multiples, which matches the return type. It's a list of int. So let's see, they brought in system collections generic for us because we were using list. That's where it resides. If you look at the doc page for list, you will notice that namespace given. I'll go ahead and test. Green is good. And we are clear for takeoff. Okay, so yeah, this is fine. Fine to submit this way. I'm going to show you how to do this all in one line using LINQ. This is a more advanced thing. It's not an 8 thing, so don't be intimidated by it or be frustrated if you don't understand it. I'm just offering it in case you want to start seeing how LINQ works. So to access that, I'm going to bring in system LINQ. And I'll show you, we're going to start with this range method, but like I said, when you're at the doc page, you'll notice it tells you the namespace system LINQ, and that's why I typed in using system LINQ. That gives me access to this range method because I didn't define it, right? If I didn't define it, I have to bring that in from somewhere, and I'm bringing it in from system LINQ. And what range is going to do is it generates a sequence of integral numbers within a specified range. So in my case, I'm going to start with 1. I just want the numbers 1 through, say, 5. But you tell it where you want to start, and then you tell it how many values you want, and it will just give you those consecutive integers. So let's start with that. I'm going to delete this solution. I assume you've had time to see it, because I'm going to send mine off with the LINQ answer. So let's start building this thing. Now, what I'm going to do with this enumerable range is I'm going to make a list of integers. So imagine, since there's 3 values here, I'm going to make the values 1, 2, and 3, or however many I need. And then I'm just going to multiply each of those values by whatever the multiple is. And so imagine if I had the range 1, 2, and 3, some collection that held those numbers, and I multiplied each of those numbers by 2, hopefully you can see how that transforms from, or it maps from 1, 2, 3 to 2, 4, 6 when you multiply each value by 2, or if you want to speak generally, by the multiple. So we can say enumerable range, and we want to start with 1. We want the values 1, 2, 3, 4, however many. And the catch is, how do you get the count? And what you have to notice for this is that you can figure out how many values you need by, you can divide the limit by the multiple. So the limit is 6 in this case. The multiple is 2, right? This is the values they pass to us. So if I take 6 divided by 2, it's 3. And sure enough, there are 3 values here. And feel free to make up other little scenarios, like the test case down here. They have 5 and 25. 25 divided by 5 is 5, and you see there are 5 values there. Same with 2 and 1. So when you realize that's generally true, you can say limit divided by multiple. And this will give us those numbers, 1, 2, 3, however many we need for whatever parameters we are passed in. Good. So this range, if you look at the return type, it's returning an IEnumerable of integer, which is just a fancy way of saying just some general collection. It's non-committal. It's not an array. It's not a list. It's just this very general multi-purpose or just very general non-committal collection that holds whatever your generic type is here. And in our case, it's an integer. So that's what we get back, and we have to realize that. So when we go here, this whole statement I have is going to return an IEnumerable of int. It's not a list, but it is a collection of integers. So what do we do with that? Remember I said, okay, we get the 1, 2, 3 from this, but now we got to transform that into 2, 4, 6. And I said we could do that by multiplying each value by the multiple. Well, you should be scanning these LINQ methods until you get comfortable or have an idea about what's at your disposal. And a very, very common one that you'll come across is select. And it's great. I love this. Projects each element of a sequence into a new form. And that's exactly what we need, right? We don't think of a new form like we have to change the type. You can change it to a new type. It doesn't have to stay integer. But in our case, it would read better if it said projects each element of a sequence into a new value. But this is generalized. It's a new form. But that doesn't mean the type changes. I just want to be clear on that. So you can see, you can read the doc page and look at some of these examples. I think they have an integer one. Yeah, so look, they used range just like we did. And then they call select. And you can see how they give it this lambda here, where it takes an integer. It has to, because that's what the type of range, the collection returned by range. And it multiplies it by itself. Or in other words, it squares the value. So you can square the values from 1 to 10, and that's what the output exactly does, squared values. So we're going to do pretty much the same thing, but instead of squaring the value, we want to multiply it by our multiple. So let's make that happen. We chain these method calls. You don't have to. You could load this first result into a temporary local variable in this function, and then you could call select on that. But I'm going to be fancy, do it all in one line like I promised at the beginning of the video. So with these lambdas, I don't want you to be intimidated by them. They're just in-place function definitions. And we do this when we don't need to use a function many times, a sort of throwaway function that doesn't even need to be named. It's anonymous. We don't need to take the time to write out a function. If you really wanted to and that made you more comfortable, you could make this function square value and implement it and then call it. But when you code a lot, you don't necessarily want to do that. So we're going to follow this form. We give our parameter name first, and when there's a single parameter, you don't need to put it in parentheses like most methods have parentheses around their parameters. Well, all methods do that, but you don't with a lambda if there's only one, so that's why. I use the variable name n because n's a common name to give to integers, but I want you to know that this part is something that you name. And then you put this arrow, and then you put the body of your method. And again, we want to say n times multiple, right? We're not squaring. We need the multiples up to a certain limit. And if we look at the doc page again, you should always know what your method is returning. Again, IEnumerable of whatever your generic type is. Ours is integer. It's going to return us this general collection of integers. So you go back and look, and you're like, oh, dang, it got all the values we wanted, but shoot, I need a list as part of the contract. What do we do now? Well, enumerable LINQ to the rescue again. You scan through your methods and you see that you have this handy toList. So I can take that wishy-washy general collection and make it into a specific collection type, a list. And this will do exactly that, toList. So you take your answer and you chain again toList. And that'll make a list of whatever type we are working with, which was integer. So I brought in system LINQ. We should be good. I'm going to test this. Let's see if I did that right. Green. And more green, my favorite color. So I'm going to go ahead and submit my answer this way, but feel free to use whichever one you want. Go ahead and review the solutions from other people. and see what you can get. Yeah, pretty much the same thing. I anticipated a lot of that. Here's somebody who implemented their own, which is just fine too. You don't have to use LINQ. Yeah, I don't know if there's going to be a lot of variation here, but feel free to scan all you like. Otherwise, that should wrap up this video. Hit me up with questions, comments, concerns. Otherwise, we will keep rolling. As usual, thank you for watching. I'll see you in another video.